Okay, so the next example we're going to do is the y equals tan of x. So in that case, tan of x just repeats itself. But because you look at the first one that's close to 0, your graph looks something like that, and that is 1 to 1. Therefore, since it's 1 to 1, if you restrict the domain now between, in this case, negative pi over 2 and pi over 2. With that in mind, now you have, if it reflects across y equals x, that means it must reflect across the line that's over here. That means my graph here is going to look something along the lines of this and that. Okay, it's going to look something like that. Now, let's look at the domain of tan. The domain of tan here is equal to, because we restricted the domain of tan in this case would be between negative pi over 2 and pi over 2. And then in this case, my range here is going to be, again, doesn't change because it goes to positive infinity and negative infinity. Okay, so in this case, okay, round brackets because you cannot include infinity. Okay, likewise, because the domain range is search for inverses, so the range here, we look at the domain of f. In this case, the domain of f, in this case, we restricted it, it's going to equal, or we have to use round brackets for this one, because if you have pi over 2 and pi over 2, negative pi over 2, those won't exist. So it's in this case, the range here is negative pi over 2 and pi over 2. Okay, the domain in this case again remains the same, so negative infinity to positive infinity. Okay, those are ratios and these are angles. Okay, so the inverse of tan is called arctan, and that's what we have. Okay, so remember, whatever you put into here, that's going to be a ratio. Okay, whatever you get out of it, it's going to be an angle. Okay, so here's an example. Let's talk about the unit circle first. Okay, the range of inverse of f is negative pi over 2 to pi over 2. Okay, let me fix that. It's round brackets. And that means we're looking at quadrants number 1 and quadrants number 4. Okay, if you look at this, we're looking positive angle, negative angle. This is positive, this is negative with tan. Okay, so in this case, this example, y equals tan, arctan of negative 1 is equal to theta. Okay, if you want to figure out what the angle is. So in that case, you can rewrite this inverse as tan of this angle is equal to negative 1. And because it's negative 1, it's definitely quadrant 4. But because we're going negative in the negative direction for angles, your angle is going to be a number that's between 0 and pi over 2. Okay, so in this case, when tan is equal to negative 1, in quadrant 4, it's going to equal negative pi over 4. In that case, it's the 45 degree angle in quadrant 4, but you're going in the negative direction. Okay, so the next thing we're going to do is do a couple examples, and then we'll walk through them, and then you have questions, let me know. Okay. So the first example is on page 372. This is an example that was present in the book. So in that case, arcsine of 1/2 is equal to theta. Now you can rewrite this as sine of theta is equal to 1/2. Because 1/2 is positive, that has to be in quadrant number 1. So in that case, where is sine equal to 1/2 in quadrant 1? The answer is pi over 6. And since the domain of sine is, the arcsine is negative pi over 2 and pi over 2 inclusive, that means this is within that range, therefore it works. Okay. Next example, arcsine of negative 3 over 2 is equal to theta. So you can rewrite this as sine of theta is equal to negative 3 over 2. Because it's negative, it's definitely in quadrant 4. So you have to think about what is the angle in quadrant 4 that where sine is equal to negative root 3 over 2. In that case, it's going to equal negative pi over 3. Okay. Next example, as you can see, sine of theta is equal to 1 pi over 2. This is not exactly what we're used to, because usually what we put in here is a ratio, and this is going to be an angle. So in this case, first thing you should double check always is pi over 2 is a number that's greater than 1. So that means it's not within the domain of f, domain of inverse of f. So that means pi over 2 is not in the domain of negative 1 and 1. In that case, the domain of sine. Therefore, this one does not exist for a solution because it's beyond that, beyond the domain of arcsine. Okay. Now let's look at example number 3 on page 374 in your textbook. The question is arc cosine of negative root 2 over 2 is equal to theta. Okay. Every time I do this, I'll add theta to it because in that case, I'll remind myself I can rewrite this as the inverse function. That means cosine of theta is equal to negative root 2 over 2. In that case, cosine is defined, our cosine is defined in quadrant 1 and 2. Since cosine is negative in this situation, it's defined in quadrant number 2. Therefore, you have to think about where's cosine, what is cosine theta, what angle we're looking at where cosine is negative root 2 over 2 in quadrant number 2. Okay, again, you have to know your unit circle. This comes out as 3 pi over 4. Okay, that's between 0 and pi, and that's within the range, so you're good to go. Next example, arctan of root 3 is equal to theta, so that means tan of theta is equal to root 3, that's what we have. Because root 3 is positive, then this angle here must be in quadrant number 1. Okay, so theta is equal to pi over 3 in this situation, because sine will give you the bigger angle. With a bigger ratio, in that case you have root 3. Okay, next example, this one is a combination of, it's a function composition of functions. In that case, you have arc cosine on the outside, cosine on the inside. But because of this question, this should come out as a ratio because you have arc cosine on the outside. But because we know cosine is an even function, the negative will disappear. Okay? In that case, because we don't have a good angle for this. So in that case, this is going to give you a ratio. So in that case, it's going to come out as 1.1 because inverse of cosine and cosine will cancel each other out. This is a very special case, okay? Now let's look at exercises 8, 10, and 12, 8 to 12. 8, 10 to 12 in your textbook. So example number 8 says, arc cosine of negative root 3 over 2 is equal to theta. And then you can rewrite it as cosine of theta is equal to negative 3 over 2. Okay? In that case, theta, you have to think about it in quadrant 2 because it's negative. So when is cosine equal to negative root 3 over 2? In quadrant 2, the answer comes out as 5 pi over 6. Okay? Number 10, arc tangent of negative root 3 over 2 is the same thing as tan of theta is equal to negative root 3. Because this is negative, angle must be in quadrant number 4. Okay, in this case, you get negative pi over 3. Okay, the reason why we can get this really quickly is because you know your unit circle. Okay, so if you don't know it, you got to keep practicing. Okay, next example, arc cosine of 0 equals theta can be written as cosine of theta is equal to 0. Okay, because this is it's in between angles, between the quadrants. But we know cosine of pi over 2 equals 0. That means this is within the domain, the range. That means we're good to go. That means my theta here, this comes out as pi over 2. Example number 12, exercise 12. Arc sine of 1 is equal to theta. So that means you can rewrite this as sine of theta is equal to 1. And that's positive, so that's in quadrant number 1. And that means we get pi over 2 because sine of pi over 2 is equal to 1. Okay? Remember, you have to know your domain and range for inverse trig and you know your unit circle. Okay? These ones are a little more challenging. These ones are more similar to the ones we did for composition of functions. But again, as I go through it, make sure you pay attention. Okay? Now the example for number 23 is cosine of inverse of sine of 1/2. That's cosine of arc sine of 1/2. Okay? What you remember here is cosine on the outside, therefore this inside must be an angle. So that means sine inverse of sine of 1/2 is equal to theta. That means theta is equal to arc sine of 1/2. Same, this is equal to each other. That means sine, rewriting this, sine of theta is equal to 1/2. And because it's positive, we have to write it as it's in quadrant 1. That means theta in this case would be pi over 6. So in that case, we found that's pi over 6. So we replace everything in here with pi over 6. So you have cosine of pi over 6, which gets you negative or root 3 over 2. Okay? Next example, sine of arctan of 1. Okay, remember, outside is sine. That means whatever is in here must be an angle. So that means arctan of 1 is equal to theta. That's what I have over here. We write this as tan of theta is equal to 1. And when is that in quadrant 1? Because it's positive, theta is equal to pi over 4. That means sine of pi over 4 is equal to root 2 over 2. So that's the answer to this question. 26, arc cosine of 7 pi over 4. This one's very similar to this one. Okay? So first, you've got to evaluate this one. So cosine of 7 pi over 4 is a very good angle. So it's going to be root 2 over 2. In this case, it's in quadrant 4. This is negative. So negative root 2 over 2. So that means arc cosine of negative root 2 over 2 is equal to negative pi over 4. Okay, what do we get out of this one? It must be between negative pi over 2 and positive pi over 2. No, 0 and pi in this situation. So this one comes out as 3 pi over 4. That's my bad. Okay? 3 pi over 4, because in quadrant 2, cosine is negative. Okay? Now, example number 27, cosine of 2 sine arcsine of 1/2. Again, you can ignore the 2 for now, but arcsine of 1/2 is equal to theta. So that means we can write it as sine of theta is equal to 1/2, which is in quadrant 1 because it's 1/2. So theta in this case would be pi over 6. So if you substitute everything back, cosine of 2 times pi over 6 is what we have, which is the same thing as cosine pi over 3, which comes out as 1/2. Okay. Number 28, sine of arctan of -1. Again, we can write this inside as a theta angle. So theta, arctan of -1 is the theta. So that means tan of theta is equal to 1, -1. Because it's -1, we're in quadrant number 4. Okay? So I should put, okay, this is quadrant number, it doesn't matter. Okay, so now what we have here is theta is equal to -pi over 4. That means we can rewrite everything as sine of -pi over 4 is equal to -√2 over 2. And we can take the negative out because sine is an odd function. Take it out and you have the same answer. Okay, that's all for now. So if you have questions, let me know via email, or you can slow this video down to whatever pace you want. So let me know. So your assignment will be posted very soon. Okay, cool. That's all for today.